Okay, good afternoon. Now, up till now, we have seen different sensors, that is encoder, resolver, LVDT, then limit switch. All these sensors we have seen. Now, today we will see pneumatic switch. Now, pneumatic means what? It is operated on air. Pneumatic means it is operated on air. Hydraulic means it is operated on it is operated on oil. Fluid means fluid consists of both liquid and gases. Therefore, pneumatic is based on air or gas and hydraulic is based on oil. Therefore, a pneumatic switch is a device that activates or deactivates an electrical signal in a system based on the level of air pressure detected by the component. A pressure switch opens and closes the electrical contact point when the pressure of compressed air reaches the designated value. It consists of the pressure receiving part, the electrical contact point that generates electrical signals, and the pressure setting part. A pressure switch monitors the air pressure, and when it goes below or above the preset value, the monitor operates a micro switch to open and close the contact point to generate an electrical signal. Pressure switches are available in four types. First is diaphragm, second is bellows, third is bourdon tube, and fourth is piston type. Now, all these four pressure switches we'll see. A pneumatic pressure switch is used for the following purposes. First, it monitors the pressure of the pneumatic power source and generates alarm signals when the air pressure drops below the preset value. The pressure stops for safety purposes. It detects pneumatic pressure of the driver apparatus to generate a signal. It detects the operation of pneumatic pressure. For example, it can be used to count the number of operations of a direction control valve. Therefore, this is nothing but pneumatic pressure switch, which is used for these different purposes. Now we'll see the first video.
the addition of reactive chemicals to the mixture allow the
Okay, this is nothing but pressure switch. Another video will see.
What is a pressure switch? Pressure switch operating principle. Pressure switch is used to measure and maintain pressure or level of liquid or gas media. There are several common applications of pressure switching. The simplest use is to activate a light or sound alarm when a certain level or pressure threshold is reached. The switch has upper and lower trigger pressure. Pressure switch can be used to switch the pump on or off when the liquid level reaches the lower or upper limit. Electronic and mechanical pressure switch. There are two main types of pressure switches, a mechanical pressure switch and an electronic pressure switch. Mechanical pressure switch. In a mechanical pressure switch, a diaphragm closes and opens the circuit when media pressure rises or drops to a certain set value. Electronic pressure switch. An electronic pressure switch is based on a pressure sensor element, electronic board that ensures precise switching thresholds and a virtually wear-free solid-state relay to switch the load. The pros and cons of mechanical and electronic pressure switches. Mechanical switch is usually the cheapest solution. Electronic pressure switches are normally more accurate and reliable than the mechanical ones. They feature easy programming of the operation logic and triggering thresholds. Electronic pressure switch can be equipped with the analog and digital outputs, and thus also serve as a pressure transmitter. Various models have digital displays for easier measurement. Thank you for your attention. In this video, we're going to talk about different types of pressure switches and how they operate. Okay, let's go. Depending on who you talk to, pressure switches fall under the pressure sensor category. Some people will tell you that a pressure sensor is a device for pressure measurement of gases or liquids. Included in this pressure sensor category, along with pressure switches, are pressure transducers, pressure transmitters, and pressure senders, among other names. It can be a bit confusing because the process define a sensor as a device uses electrical output in response to that change. And just to add even more confusion, the terms pressure sensor, pressure transducer, pressure transmitter. Now that we've got this, let's dig into the device, which is the focus of this video, the pressure switch. First of all, let's start by defining what a pressure switch is. A pressure switch is a two-part device consisting of a sensing transducer and an electrical switch. The electrical switch opens and closes at a specific pressure, often referred to as the set point. Depending on the switch and the vendor, the switching pressure set point may be fixed or adjustable. A transducer is a device that converts one form of energy to another. So, the transducer part of the pressure switch is the piece that comes in contact with the process under test. Then somehow, the transducer has to operate the electrical switch. Vendors produce pressure switches using different types of transducers and different types of switches. Before we go any further, let's clear up any confusion you might have about the difference between a pressure switch and a pressure transmitter. A pressure transmitter has a transducer just like a pressure switch. That's where the similarity ends. The output of a pressure transmitter is an analog electrical voltage or a current signal representing 0 to 100% of the pressure range sensed by the transducer. Okay, now that we've got that cleared up, let's get back to the pressure switch. There are two different types of pressure switches, electromechanical and solid state. Electromechanical pressure switches all have traditional style mechanical switches with moving parts. There are a variety of different types of transducers that are used to mechanically operate the switch, such as diaphragm and Borden type. Diaphragm switches use a metal diaphragm to operate the switch. Borden tube switches use a Borden tube to operate the switch. Solid state pressure switches have no moving parts. Electrical switching is accomplished by operating a semiconductor device, such as a bipolar junction transistor or a field effect transistor. A typical transducer used on a solid state pressure switch is a strain gauge Wheatstone bridge. The term electronic pressure switch is slowly replacing the term solid state pressure switch. The electronic pressure switch is solid state, but much more versatile. It offers options such as programmable functions, LED displays, multiple and adjustable output switch configurations, such as normally open, normally closed, or both. Which type of pressure switch is better, the electromechanical type or the solid state type? As with all instrumentation, the choice between the two depends upon the application. Solid state pressure switches provide several advantages over electromechanical switches, such as longer life, better accuracy, shock and vibration resistance. Generally speaking, electromechanical switches are capable of switching higher currents and are not voltage dependent. As with other electrical devices, there are several different symbols used on schematics to represent pressure switches. Let's look at pressure switch symbols as designated by two industry-recognized standards organizations. Here are two symbols from the National Electrical Manufacturers Association, or NEMA, and International Electrical Commission, or IEC. This is the symbol for an SPST normally closed pressure switch. The switch on the left is NEMA, and the switch on the right is IEC. This symbol indicates that the switch will open with an increase in pressure. This is the symbol for an SPST normally open pressure switch. Once again, the switch on the left is NEMA, and the switch on the right is IEC. This symbol indicates that the switch will close with an increase in pressure. This is a good time to mention that all pressure switches on a schematic diagram will be shown in their de-energized condition, or in other words, the condition they would be in sitting on a shelf. Let's examine a couple of pressure switches on schematics. ES101 is a normally closed switch that will open on an...
Okay, now we will see next. Now pneumatic pressure switches are classified into four types: diaphragm type, bellows type, bourdon tube type, and piston type. Now we'll see one by one. First is diaphragm type pressure switch or direct type pressure switch. A diaphragm type pressure switch, as shown in figure, uses a diaphragm to receive the pressure when air pressure reaches the diaphragm through the inlet wall. The top of the diaphragm is pushed up to create a force that is greater than the compressive force of the spring. Now this I will explain. First of all, just I will read. Then the diaphragm elevates to operate micro switch to open and close electrical contact point. When air pressure drops, both the diaphragm and the micro contact point returns to their original positions. A diaphragm type pressure switch sees low friction with the driving apparatus, so it has low hysteresis, that is an output of a system that depends on input and history of input. In some cases, the diaphragm's displacement is used to open and close electrical contact points to ensure highly stable performance. Therefore, I will explain this figure now. Sorry. See that here inlet pressure is there. Now this is the diaphragm. This is the diaphragm. Now when the pressure will increase, what will happen? This diaphragm will be having some convex shape. Now it is having concave shape. It will that shape will be turned into convex shape so that this switch will be there or this plate will be there. It will be raised, and once it will be raised, this micro switch is there. This point will touch to this point, and also spring will get compressed, and this point will touch to this point and switch will get activated. And when pressure drops again, therefore diaphragm will return to its initial shape, that is concave shape. Concave means antarvakra, convex means bahirvakra. And this plunger is there, it will also come down, and this pointer or this contact point is there, they will not be having any contact in between them. Therefore, like this diaphragm type pressure switch works. We'll see the video. See that this is the diaphragm. See that how this it is working. Once the diaphragm will come down, this wall is closed. Therefore, this is diaphragm type pressure switch. Now next is bellows type pressure switch. The bellows type pressure switch shown in figure, only figure 3, sorry, has a pressure receiving part here, inlet pressure receiving part, that consists of bellows. See that this inlet is connected to this bellows. Bellows means you may have seen in at our house also. We are taking out that groundnut oil with the help of that pump. Small pump is there, and we are pumping it. That is nothing but bellows. You may have seen somewhere else, or you may have operated with your hand also. When the input signal pressure enters the bellows, the lever moves counterclockwise. Here you will see the first of all construction. It consists of bellows. It is connected to the inlet point. This is the setting screw. This is the main setting screw. This is the micro switch. This is electrical contact point. When the input signal pressure enters the bellows, the lever moves counterclockwise until the compression of the main spring matches the force of the bellows, and the micro switch is operated by the lever. Therefore, what will happen when this inlet pressure or input pressure is given? This bellows is going to expand. Bellows is going to expand, and since this lever is there, what will happen on this lever? This screws are placed and on these screws springs are there. Therefore, when this lever will go up, therefore at that time what will happen? The spring will get compressed. The bellows is either made up of phosphor bronze or beryllium bronze stainless steel, and it is generally used for pressures between 0 to 20 centimeter square. A double bellows structure is also above 40 centimeter square. Note that bellow type pneumatic switch has a greater hysteresis value. Therefore, like this it operates. When this bellows will expand, this it will move anti-clockwise, that is this point lever end point, it will go up, therefore spring will get compressed, and therefore this micro switch will come down, it will connect here at this contact point, and it is getting operated. Now pneumatic switches again, board on tube and piston type. First of all, we'll see board on tube pressure gauge. Now board on tube pressure switch, I will show video also. A board on tube pressure switch uses the board on tube manometer. It has high accuracy and durability, but the board on tube might deflect under high pressure. Therefore, what is happening? You just see when this inlet pressure is given. Now this is the board on tube. It is of elastic material. What is the characteristic of this board on tube? When inlet pressure is given, when pressure will increase, this board on tube will expand. Board on tube will expand like this, and when it will expand, this point will touch here, and automatically here this electrical contact point will touch this setting screw, and this pressure, it is showing the actual value of the pressure. Therefore, we will see this board on tube pressure gauge. Board on tube gauge means switch, pressure switch. This small video will see.
The operating pressure in hydraulic or pneumatic systems is measured with respect to atmospheric pressure by pressure gauge. The most common pressure gauge design was contrived by Eugene Borden. It used a curved tube design as the pressure sensing element. The pressure gauge with Borden tube contains case, socket, Borden tube, plate, mechanism, dial with scale, pointer, window, ring. The pressure gauge housing is most often made of stainless steel or plastic. Board and tube is made of copper, brass or bronze. The pressure difference between the pressure in the system and atmospheric pressure causes the free end of the board and tube to deflect accordingly. Movement is transferred via the mechanism to the pointer. At this moment, the pressure decreases and the board and tube returns to its first position. The accuracy class for pressure gauges is expressed as a percentage of the span. For example, class 0.6 is class for pressure gauges with absolute accuracy better than 0.6% of the nominal full scale reading. The readings of these gauges are slightly different. It's normal. These pressure gauges have different accuracy classes.
Okay, this is nothing but board on tube pressure gauge. Now next, piston type pressure switch. A piston type pressure switch shown in figure combines a piston and a resistance spring. in the pressure receiving part and allows a wide range of displacement. However, it requires a seal to prevent any leakage from the piston. The seal increases friction and lowers accuracy. The range of available pressure is about 10 to 100 centimeters square and is mostly suitable for special high pressure applications. Now I will explain this. See that this piston type pressure switch consists of this piston which is connected to this inlet port. Above this piston, this plate is there, and on this plate, this spring, compression spring is placed, and this is the setting screw to adjust the compression in the spring. Now what will happen when this input pressure signal is given? If pressure increases, what will happen? This piston will move in upward direction. At the same time, it will compress the spring, and whatever this plate is there, it will operate. This plate is going to operate this micro switch, and it will indicate the pressure. Therefore, piston type pressure switch, we will see its animation.
With the Rockwell quick change system from Hip-Axis, you can simplify your program.
1 minute.
Reduce
Piston type.
increase productivity.
Okay, in the first video itself, this piston type pressure switch is there. Already we have seen this.
Liquid or gaseous pressure moves a piston turn operates the switch. The process and its pressure are on one side of the piston, and the switch is on the other. Add a switch, the piston can return to its original position when the pressure drops, and you have a mechanical pressure switch. Pretty simple. However, while early pressure switches were sound in principle, they didn't perform well because of some inherent problems. First of all, because the piston must travel a long distance, it subjects the sealing ring and the switch to considerable wear and leakage. SOR solved those problems in 1956 by using a non-moving or static O-ring and a diaphragm between the process and the piston head. The static O-ring and diaphragm keep the switch dry. For that matter, even dry. The O-ring remains static at all times. It doesn't suffer the wear of moving parts. Let's review. Pressure moves the piston, which pushes against the diaphragm. A calibrated spring and area of piston determines how much pressure it takes to move the diaphragm. As the diaphragm moves, it flexes and presses against the switch. The switch activates to control whatever causes the pressure to build up, such as the addition of reactive chemicals to the mixture, amount of gas or liquid in the process container, and so on. When the pressure diminishes, the spring takes over and the piston returns to its original position.
And therefore, this is nothing but piston type pressure switch. Now next, pressure transducers. A pressure transducer, sometimes referred to as a transmitter, is a device that turns pressure into an equally proportional electrical signal. Transducers use variable pressure sensors to measure deflection and resistance. The produced signal will be either a voltage, current, or frequency based on the applied pressure. Transducers typically produce one of three types of output: millivolt, voltage, and milliampere. The majority of transducers have a pressure sensitive element that reacts to pressure entering through the transducer's pressure port. As the sensing element or diaphragm is deflected due to the pressure force, it moves in relation to a resistor or capacitor plate. This in turn sends an output signal that is determined by the varying tension between the input signal, diaphragm position, and core resistance. Therefore, we will see the video of this. Whatever videos we have seen of pressure pneumatic type switches, same is for pressure transducer.
We don't stop at making our products faster and smaller. We make them more sustainable. Dell Technologies pushes the boundary.
You know that you can get a great discount on Siemens PLC starter kits when you get a Real Parts Pro membership? Check out the links in the description. Over the years, the terms sensor, transducer, and transmitter have become confusing because they're often used interchangeably and indiscriminately by different vendors. The terms sensor and transducer have been around for a very long time, but in the world of process control, the term transmitter is not very old. In particular, the term transducer is tossed around as a name for many devices and instruments. If you conduct a web search of the terms sensor and transducer, you'll get lots of different definitions. Many organizations have their own definitions. Just to confuse the issue, sensor and transducer have often been used as synonyms. Okay, let's start with some suitable definitions that we'll use in this video. A sensor is a device or element that performs the initial measurement as it senses the changes in a physical variable. A sensor is a device that makes physical contact with the variable being measured and detects changes and provides a corresponding output signal that can be measured. A transducer is a device that converts one form of energy to another. A transducer provides an output quantity having a specified relation to an input quantity. In the field of instrumentation, the output quantity is an electrical or electronic signal. So, we say that a transducer measures pressure, load, force, or other states, and converts the reading into an electrical or electronic signal. For example, a strain gauge is a transducer whose resistance value changes proportionally to the strain it experiences. Here's an interesting statement. All sensors are transducers, but not all transducers are sensors. What do we mean by that? Well, consider a loudspeaker that converts an electrical signal into motion. The speaker is a transducer, but not a sensor. All right, let's talk about the term transmitter, because it has more than one definition. The process control term was likely borrowed from the telecommunications world, where a transmitter is a device that produces and transmits radio waves radiating from an antenna. These radio waves are eventually detected and demodulated by a radio receiver. The receiver produces sound waves for the human ear. In the world of process control, a transmitter is a device that transmits a standard instrumentation signal representing a physical variable being measured. The standard electrical signals are 1 to 5 volts or 4 to 20 milliamps, which represents 0 to 100% of the physical variables being measured. This transmitted signal is detected by a receiver, such as an analog input on a PLC or a DCS. So, we just said that the transmitter signal represents the physical variable. How does the transmitter know what the physical variable is? That's where a sensor or a transducer comes into the picture. A sensor performs the initial measurement. If necessary, a transducer converts this initial measurement into an electrical signal that is then amplified and standardized by the transmitter. Here's an example. We're measuring a process pressure with a range of 0 to 100 psi. Our sensor transducer performs the initial measurement and converts it to an electrical signal of 0 to 3 millivolts. The transmitter then converts that signal to a standard signal of 1 to 5 volts, which is received by a PLC analog input module. Many vendors use the terms pressure transmitter and pressure transducer interchangeably. But we now know that the two devices are not the same. So it's buyer beware. If you're curious, conduct a web search of the two terms, and you may be surprised at the results. Let's talk about a pressure switch. A pressure switch is a two-part device consisting of a sensing transducer and an electrical switch. Is a pressure switch different than a pressure transmitter? There are some common components, but they are functionally very different. A pressure switch has a transducer just like a pressure transmitter. That's where the similarity ends. As we've already discussed, a pressure transmitter produces an analog electrical voltage or current signal representing 0 to 100% of physical process pressure. A pressure switch has electrical contacts that open and close at a specific pressure. Can a pressure transmitter be used to function as a pressure switch? The answer is absolutely yes. But is it really worth it? First of all, a pressure transmitter is larger, more expensive, and often more difficult to install. There are other deterrents as well. Let's illustrate with an example. We have a process control system where we need to open a valve when the pressure in a pipe reaches 50 psi. We can use a pressure transmitter calibrated to produce a 4 to 20 milliamps output for a pressure range of 0 to 100 psi. We need an analog input module on our PLC, and we need to scale the analog module and insert code into the PLC program so that the 50 psi value triggers an event to open the valve. It's much easier to use a pressure switch connected to a simple PLC digital input module. The PLC valve control logic is much simpler as well. Bottom line, if you don't need to know the exact pressure and only need to know when a specific pressure point is dropped below or risen above a set point value, then stick with a pressure switch. Okay, let's summarize what we've discussed. A transducer is a device that converts one form of energy to another. A sensor is a device or element that performs the initial measurement of a physical variable. All sensors are transducers, but not all transducers are sensors. All pressure sensors, pressure switches, and pressure transmitters must have a sensing transducer. A pressure switch consists of a transducer and an electrical switch that opens or closes a contact at a specific pressure. A pressure transmitter is a device that converts the electrical signal from the transducer into a much larger electrical signal. A transmitter output signal is usually a range of voltage, 1 to 5 volts, or current, 4 to 20 milliamps, representing 0 to 100% of the sensed physical variable. A pressure transmitter can be used as a pressure switch, but it is not practical to do so. As mentioned at the beginning of the video, you will get a nice discount on Siemens PLC starter kits to become a Real Mars Pro member. After signing up,
This is nothing but pressure transducers. Now, next point is proximity sensors. Proximity sensors are sensors that detect the movement or presence of objects without physical contact and relay that information captured into an electrical signal. Proximity sensors is nothing but laser sensors. We have seen laser tachometer. That is when we are focusing that laser beam on the rotating part, we are getting the RPM. Applications of proximity sensors. Safety of humans and robots for avoiding collisions. Inventory management. Object detection, positioning, inspection and counting. Part detection in an industrial conveyor system. In smartphones to detect how far a user is holding the phone from body parts. Capacitive switches in appliances. Diffuser sensor in a public washrooms. Therefore, this is nothing but proximity sensors. Now, types of proximity sensors. First is inductive proximity sensor. Now its there is there. First of all, we'll see its video, then I will explain this. What is meant by inductive? First of all, I will tell the construction. This is the amplifier. This is the Schmidt trigger. Then here amplitude drops are there. Then here reluctance shifts are there. Then this target is there. In the target, that is this magnetic flux lines are there. When these magnetic flux lines are moving from one end to another end, and if you will place target in between the magnetic flux lines, these magnetic flux lines are cut off. And these magnetic cutoff magnetic flux lines, they will induce AD currents in the target. Now this what these AD currents will do, these AD currents will oppose these original magnetic flux lines. They will oppose the transmission of this original magnetic flux lines. Therefore, first of all, we'll see the video.
Hello everyone, welcome to Instrumentation Academy. In this video, we will discuss how a PNP and Npn proximity sensor works. We have already discussed about how a proximity sensor works in our previous video. Link of that video is there in the description box. Let's consider a circuit in which a light bulb is connected to a battery using two wires. Positive terminal of the battery is connected to one side of the bulb and the negative terminal is connected to the other side of the bulb. Now current flows from the battery through the light bulb and back to the battery. That is all it takes to light the bulb. Now if you want to switch on or off the bulb, this can be done in two ways. The first way is to install switch on the wire that runs from the positive terminal of the battery to the light bulb. And the second way is to install switch on the wire that runs from the negative terminal of the battery to the light bulb. Now switch 1 is set to switch the positive side of the circuit, while switch 2 is set to switch the negative side of the circuit. Here the bulb connected in the circuit is the load. By switching the positive side of the circuit or by switching the negative side of the circuit, the connected load can be controlled. In proximity sensors, bipolar junction transistors are used for this positive side switching or negative side switching of the circuit, and this switching helps to control the load connected to the proximity sensor. Bipolar junction transistors are of two types, NPN transistor and PNP transistor. An NPN transistor is constructed by sandwiching a p-type semiconductor between two n-type semiconductors, and a PNP transistor is constructed by sandwiching a n-type semiconductor between two p-type semiconductors. The transistor has three terminals, namely base, emitter, and collector. PNP transistor is used for switching the positive side of the circuit, and NPN transistor is used for switching the negative side of the circuit. Let's now discuss the construction of PNP and Npn proximity sensors. PNP or Npn proximity sensor consists of a proximity sensor circuit and a PNP or Npn transistor circuit. The purpose of sensor circuit or proximity sensor circuit is to detect any nearby object. When the sensor circuit detects an object, it sends an output high signal to the transistor circuit. The transistor-based circuit may use PNP or NPN transistors, and it depends on the application that sensor is used for. PNP and NPN has nothing to do with whether the sensor is normally open or normally closed. That means a PNP sensor may be either normally open or normally closed. Likewise, an NPN sensor can also be normally open or normally closed. Now let's discuss about a 3-wire PNP proximity sensor. A 3-wire proximity sensor consists of 3 wires, in which the brown wire is used to connect the positive voltage, the blue wire is used to connect the negative voltage or ground, and the black wire is the sensor signal output wire. In a PNP proximity sensor, we know that a PNP transistor is used for positive switching. So a PNP transistor is installed between the positive voltage wire and sensor signal output wire. As negative voltage will be common between sensor and load, connect negative voltage wire to sensor and the load. Signal output wire of the sensor is connected to the input of the load. A load can be any device that the sensor powers, like a lamp, pneumatic valve, relay, or PLC. In this circuit, let's consider a bulb as load which need to glow when a metal object is detected and switch off when no object is present. When a PNP proximity sensor doesn't detect any metal object, the signal pin output will be low, and so the transistor and the bulb will be off. When a metal object is detected, the sensor will output a voltage of almost nearly the same as the voltage fed into the positive voltage pin, and hence the transistor will be on, and so the bulb will be switched on. Now let's discuss about 3-wire NPN proximity sensor. A 3-wire proximity sensor consists of 3 wires. As discussed earlier, the brown wire is used to connect the positive voltage, blue wire is used to connect the ground, and the black wire is the signal output wire. In an NPN proximity sensor, we know that NPN transistor is used for negative switching. So an NPN transistor is installed between the negative voltage wire and the sensor signal output wire. As positive voltage will be common between the sensor and the load, connect positive voltage from the power source to the sensor and the load. A permanent positive supply will be connected to the load that is to be activated. Signal output wire of the sensor will be connected to the input of the load. NPN proximity sensors are different from PNP proximity sensors. NPN transistors are on naturally. That means they emit high signal when no metal object is detected and goes off or low when an object is detected. NPN requires more circuits in order to switch on when an object is detected and switch off when object is not detected. Usually an inverter circuit is used to make the high output of the NPN low when there is no object, and also to make the low output of the NPN high when an object is present. Let's consider a bulb as load which need to glow when metal object is detected and switch off when no object is present. When no object is detected, as NPN transistors are naturally on, they emit a high signal on the signal line that has a voltage just above the voltage fed into the positive voltage pin, that is the brown pin. This high signal is fed into the input of an inverter, and the inverter inverts it into a low signal. Thus, with this low voltage, the bulb cannot be powered on. When a metal object is detected, a low signal is emitted on the signal line of the transistor. This low signal is fed into the input of an inverter, and the inverter inverts it into a high signal. Thus, with this high voltage, the bulb is powered on. By this, we come to the end of this video. If you like our
Therefore, this is nothing but video of the inductive type. Now they have shown in the video only PNP and NPN type proximity transducer. We have inductive type. Inductive type means, always remember, inductance is there. Inductive type means inductance. Therefore, inductive type proximity sensors are contactless sensors used to only detect metal objects. It's based on the law of induction, driving a coil with an oscillator once a metallic object approaches it. An alternating current is supplied to the coil, generating an electromagnetic detection field. See that here. An alternating current here is supplied to the coil, which will generate electromagnetic induction or magnetic flux. When a metal object comes closer into the magnetic field, AD currents build up. That is whatever I have told. These magnetic flux lines are moving from one end to another end. Now what will happen when this metal plate or metal object will come in between the magnetic flux lines? Magnetic flux lines are cut off, CUTOWF. Therefore, because of this cut off magnetic flux lines, AD currents are induced in the plate. And these AD currents will oppose the movement of these magnetic flux lines. AD currents build up and result in coil inductance change. When coil inductance changes, the circuit that has been continuously monitoring will trigger the sensor's output switch. Therefore, when the coil's inductance will change because of this cut-off magnetic flux lines, it will trigger the output switch. Now, what are the advantages? Contactless detection, environment adaptability, resistant to common conditions seen in industrial areas such as dust and dirt, capable and versatile in metal sensing, considerably cheap when it comes to price, no moving parts, ensuring a longer service life. Disadvantages: lack in detection range, averaging a maximum range of up to 80 mm, can only detect metal objects. Performance can be affected by external conditions, extreme temperatures, cutting fluids, or chemicals. Therefore, this inductive type proximity transducer, 1 minute, we will see that video. Earlier video was somewhat, it was not related to that. Inductive type proximity sensor. 1 minute. Okay, this video we'll see and then we'll stop. Now it is explaining both inductive type and capacitive type.
In this video, we will discuss what is a proximity sensor and how it works. Proximity sensors are sensors that detect the movement or presence of an object without making physical contact with the object and converts that information captured into an electrical signal. Devices such as limit switches detect an object by physically contacting it, but proximity sensors detect the presence of an object without touching it. As these sensors are non-contact sensors, they do not cause any damage to the object. Proximity sensors do not use any type of physical moving parts. Instead, they allow signals to transmit through them when something that is being monitored comes in close proximity of the sensing area. There are many types of proximity sensors, and they each sense the presence of an object in their own distinct ways. The two most commonly used proximity sensors are the capacitive proximity sensor and the inductive proximity sensor. Now let's discuss about capacitive proximity sensors. Working principle of capacitive proximity sensor. Capacitive proximity sensor is based on the principle of a parallel plate capacitor. Parallel plate capacitor consists of two parallel plates that are separated by a dielectric material, which is a poor conductor of electricity, such as plastic, glass, or porcelain. The two parallel plates are conductive and they are usually made of aluminum, tantalum, or other metals. A metal plate typically has an equal amount of positively and negatively charged particles, which means it is electrically neutral. If we connect a power source or a battery to the capacitor, a large number of electrons start moving from the negative terminal of the battery through the conductive wire. When these electrons reach the right side plate of the capacitor, the dielectric material will strongly oppose the movement of electrons from the right side plate to left side plate. As a result, number of electrons, that is the negative charge carriers on the right side plate of the capacitor, will be higher than the number of protons, that is the positive charge carriers. Due to this, the right side plate of the capacitor becomes negatively charged. At the same time, the electrons on the left side plate experience a strong attractive force from the positive terminal of the battery. As a result, the electrons leave from left side plate and will be attracted towards the positive terminal of the battery. Due to this, the number of protons will be higher than the number of electrons in the left side plate, and as a result, the left side plate of the capacitor becomes positively charged. This is how the charging of capacitor takes place. The right side plate has now developed a net negative charge and the left side plate has developed an equal net positive charge. This creates an electric field with an attractive force between them which holds the charge of the capacitor. The ability of a capacitor to store electric charge when a voltage is applied is called capacitance, and quantity measuring the ability of a dielectric material to store charge is called dielectric constant. The capacitance of a capacitor is directly proportional to the dielectric constant of the material between the two plates and inversely proportional to the distance between the two plates. There are two types of capacitive proximity sensors. The first one is dielectric type capacitive proximity sensor and the second one is conductive type capacitive proximity sensor. Dielectric type of capacitive proximity sensor. Dielectric type of capacitive proximity sensor can detect any target that has a dielectric constant greater than air. It has two parallel plates inside the sensing head which operates like an open capacitor. Here air acts as the dielectric. When no target is present, the capacitance between the plates will be very less. These plates are linked to an oscillator and a detector circuit. As the target which has dielectric constant more than air comes near to the sensor, the capacitance between the plates increases. Increase in capacitance increases the amplitude of the oscillation of the oscillator. When the oscillation exceeds a specific value, the detector turns on the output of the sensor. When the target object moves away from the sensor, the oscillation amplitude decreases, and when it falls below a threshold value, the sensor returns to the initial state. Dielectric type capacitive proximity sensors will sense both metallic and non-metallic objects. Conductive type of capacitive proximity sensor. In conductive type capacitive proximity sensor, there is only one capacitor plate inside the sensor. The target itself becomes the other plate of the parallel plate capacitor. The plates of a parallel plate capacitor should be conductive. So this type of sensor is used if the target is an electrically conductive material. The air gap between the sensor and the target functions as the dielectric. The plate inside the sensor is connected to an oscillator circuit that is used to generate an electrostatic field. As the conductive target approaches the sensor, the distance between the two plates decreases, due to which the capacitance increases and results in increase of oscillation amplitude. Once the oscillations exceeds a predetermined value, output signal from the sensor is generated, which indicates that the target has reached near the sensor.
99% of businesses fail to grow their revenues and profits for two reasons.
Now let's move on to inductive proximity sensor. Inductive proximity sensors are used to detect metal targets. An inductive proximity sensor has four main components. The first one is the coil. The coil generates necessary electromagnetic field. A cup-shaped magnetic core holds the coil. This core is necessary to concentrate the coil's magnetic field on the front area of the sensor. The second part is the oscillator. The oscillator is generally an LC oscillator. It produces radio frequency, which helps to generate an electromagnetic field. The third part is the trigger circuit. The trigger circuit senses the change in amplitude of oscillation and gives the signal to the output circuit. The last part is the output circuit. The output circuit has a transistor. After receiving the signal, the transistor switches on and gives an output. Working principle of inductive proximity sensor. Inductive proximity sensors operate on the basis of Faraday's law of inductance. According to Faraday's law of induction, when an electrically conducting object is placed in a time-varying magnetic field, an electric current called eddy current will be generated in the object. And according to the Lenz's law, the eddy current creates a magnetic field in a conductor, and this eddy current magnetic field opposes the magnetic field which created it. Now let's discuss the working of an inductive proximity sensor. The proximity sensor is installed in the area where we need to sense the presence of an electrically conductive target object. When the sensing coil in the oscillation circuit is supplied with an alternating current, a changing magnetic field is created around the coil. When the target object enters this electromagnetic field, some of the electromagnetic energy is transferred to the object. According to Faraday's law of induction, an electric current called eddy current will be generated in the object. This eddy current produces another magnetic field called eddy current magnetic field, and it opposes the magnetic field which created it. As the eddy current magnetic field opposes the magnetic field of the coil, the intensity of the magnetic field of the coil reduces. As the target comes very close to the sensor, the eddy current increases, decreasing the amplitude of the electromagnetic field. The trigger circuit monitors the amplitude, and when the amplitude goes below a predetermined level, the output state of the sensor switches from its normal condition. As the target moves away from the sensor, the amplitude of the electromagnetic field increases, and at a predetermined level, the trigger switches the output state of the sensor back to its normal condition. By this, we come to the end of this video. If you like our video, please click the like button below and make sure to click the subscribe button and the bell icon also, so that you can.
Okay, this is nothing but inductive type proximity sensor. Now this capacitive type proximity sensor that I will explain afterwards. Now we will stop here. Thank you very much. Thank you. I have taken your attendance. Now you can leave the meeting. Thank you very much.